Okay, here we go on surface area. So surface area is one of those types of problems in mathematics that can look really complicated. You have all these figures and dotted lines showing what the backside of something looks like. So it's really important that you break it down into steps. The first thing that you should do is you should take a look at the figure and look for certain characteristics. For example, this is an isosceles triangle. So when we look at this very first triangular prism, we can see that this end is an isosceles triangle. This 10 along this side, the 10 right here, is the same as the 10 along this side. We see it right there. That tells us that the two side rectangles on this figure are going to be the same dimension. So the rectangle on this side, let me get rid of all of those lines. Let me get rid of every single line that we've got there so far. So this rectangle right here, this side, is going to be the very same, let's get rid of that again, is going to be the very same as this side. And notice when I shade them in, suddenly the direction of it can even look like it changes some. What that tells us is that we are going to find those two sides with the same surface area. So we're going to break down into our steps now. So step one, for every prism, whether it's this kind of triangular prism, this right triangular prism, or this rectangular prism, or even if it was a cylinder, like a Coke can, that's a cylindrical prism. For every one, we're going to find the end piece first. It just gives us a way to start. So let's go ahead and find the end piece. And on this prism, since this is a triangle, we know that to find the end, we have base times height divided by 2. That's the area of that triangle. In this case, the base is that 12. The height is this 8 right here. We don't want to get confused by this 10. This 10 is a diagonal edge here. It's the 8 that's the height divided by 2. Well, 8 times 12 is 96 divided by 2, and 96 divided by 2 is 48. We're going to have two of those that are a size of 48 because we have it at this end. That little thing keeps showing up. Let's get rid of that. This end is a 48, and this end is a 48. In fact, one of the things that's helpful is when you look at this, it has 5 sides to it. So we know we're going to need 5 numbers. And 2 of those numbers are going to be 48. So I'm going to put a 48 right here, and I'm going to put a 48 right here. I'm going to add my numbers down the side. Now I'm ready to look at this face of the prism. We call these edges faces. This prism has 5 faces. This face is 15 by 10. So this face, let's change up my color a little bit. This face will be 15 by 10. Not 15 by 10 divided by 2, because it's a rectangle. So the area for a rectangle is length times width. So 15 times 10 is 150. So I'm going to add a 150 to my list. The other side, let's go ahead and get rid of that. The other side that's on the top, not the bottom, the other side on the top has the same measurements. This side right here is also 15 by 10. This 15 is the same as this 15 on top. You've got the 10 running up the side here. So I don't need to do any computation for that one. I know that it is also 150. Okay, let's get rid of that line. And let's figure out the 5th face. And the 5th face on this is the bottom. And that bottom is 12 by 15. So 12 by 15. And let's bust out our calculator, all right? We could have been using the calculator all this time. We haven't really needed it till now, but let's go ahead and get that out. 12 times 15. Remember, we're okay using a calculator because our goal here is really to understand the problem, not to practice our multiplication. So we have all 5 sides to add together, and I would recommend you show your 5 sides. So 5 sides to add together. The 180 is already in the calculator. Add 150 to it. Oh, I guess it got rid of the 180. That's all right. We'll just put all these in. Let's put the 180 in. You can see the numbers across the top. We've got 3 of the 5 sides. There's the 4th side, and there is the 5th side. And this comes to a total of 576. So this figure, figure A, is 576, and since it's area and it's meters, it would be meters squared. Let's move the calculator out of the way, put it down here temporarily, and let's look at our second figure. So I'm just going to draw myself a line right here, separate those 2 figures out. This second, so our next figure also has 5 faces. So we're also going to have 5 numbers. Now for this figure, this is not an isosceles triangle prism. This is a right triangle prism. And what we know about a right triangle prism is, since it's not isosceles, since these 2 legs aren't the same size, we actually have 3 faces that all have different measures. So I'm going to get rid of that, and we're going to start with the measure of the end. And in this case, the end, again, it's base times height divided by 2. So 5 times 12 divided by 2. 5 times 12 is 60 divided by 2. And that's going to be 30. And we're going to have 2 faces then that measure 30. We're going to have the triangle at this end. Let me get my highlighter out again. The triangle at this end and the triangle at this end. Notice we didn't get confused by the 13. The 13 is the hypotenuse. It's not one of the legs. The legs are the height and the base. All right, let's get rid of those triangles. Let's get the highlighter out again, change up the color. And now we're going to find the length of that. Now notice, as soon as I highlighted it, for some of you, your eyes might have changed. It might have gone from looking like the back to looking like more of a front. But in any case, it's 12 tall and it's 14 wide. This 14 length right here that I'm tracing with my highlighter, this 14 right here also is that 14 at the top. So that particular part of it is 12 by 14. 12 by 14, which means 12 times 14. Let's bring up our calculator, clear everything out. 12 times 14 gives us 168. I'm going to add that to my 5 numbers. Okay, so now that's a horrible 8. Let's try that again. That's a better 8. So now I have 3 of my 5 numbers. Let's go ahead and get this. Now you might be thinking, man, he's going so slowly through this explanation. Well, I really want this to be thorough for you, so we're not rushing it. Okay, now we've got the 4th face, and it's that face, and we can see that it is 13 by 14. So we have 13 by 14. So it's one more 14 than this 168. But let's go ahead and do it in the calculator. So it's 13 by 14, 182. 182. We're going to add that to our list of faces. Let's take that highlighting away. And the last face we have is the bottom. And the bottom of this figure, let me pick a good bottom figure color for my highlighter. the bottom is right here. And so the bottom is 14 by 5. So the bottom is 14 times 5, and 14 times 5 is 70. And that is the fifth value. So 70 plus the 182 plus the 168 plus a 30 and one more 30. You can see my calculator has 1, 2, 3, 4, 5 numbers in it now. All of that equals 480. So this figure is 480 meters squared. Okay, we are down to our rectangular prism. The nice thing about saving rectangular prisms to the end, they're the easiest, even though they have the most faces. So this figure has 6 faces. When we add up our numbers, we're going to add up 6 numbers. The thing that makes them easier is that with a rectangular prism, the opposite sides are the same. If you have right now, you can pause for a minute. If you have a Kleenex box at home, grab that Kleenex box and put your hands on each side of it. And the parts that your hands are touching, no matter how you hold it, when you're holding 2 opposite sides, they have the same area. So what we know is, we know that the area of that end is the same as the area of that end. So let's do those that I just highlighted first. We'll keep our gray color here. It's 13 by 5, or 5 by 13. You can say it either way. It's not divided by 2. It's not a triangle. So it's 13 times 5. 13 times 5 is 65. So we put up the 65, and then we put up the 65 again, because we're getting both ends. Okay, let's take those out of here. Let's change up the highlighter color to that dark blue. And now we're going to find this part of the box, and it will be identical to that part of the box. They're on opposite sides of this rectangular prism. Again, holding that Kleenex box, opposite sides of the box. And those will be 14 by 13. See that 13 that's right here is the same 13 that's right here. So this is 14 times 13. 14 times 13, 182. And that 182 will get used twice. It's the opposite sides of the box. Okay, let's get rid of its shading. And we have the top and bottom left. Given how our box looks here, we have the top and the bottom left. So we have this piece, which is identical to this piece. And we can see that these are 14 by 5. So we are going to have 14 times, man, I said 5 and I wrote 3. Go figure. 14 times 5. So 14 times 5 is 70. And once again, we're going to use that 70 twice because it's a top and a bottom. Again, this is why rectangular prisms are a little bit easier, because you only have to do 3 calculations to get 6 sides. Okay, so we have 70 plus another 70 plus a 182. Oh, my calculator just, well, let's just start again. Plus a 182. All right, let's put those 70s in. They got erased accidentally. And then we had 65 twice. So I'm going to check 1, 2, 3, 4, 5, 6 numbers. Yes, they're all there. That gives me a total of 634. So that is 634 meters squared. I can put my calculator away now. Order the shapes from least to greatest. Well, B was the smallest at 480. A came next at 576. The rectangular prism was the largest at 634. Okay, so I know that took some time, and I know you have one more set below. Be sure that if there was anything new that you got out of this, if you said, oh, I didn't understand that, if you've already done the problems below, see if you need to make any changes. Don't just watch the video again, but actually go in, make changes based on what you just learned, and then watch the video for that section. All right, here we are with the bottom of the page. And our process is going to be the same. I'm going to go through first and identify this prism has 5 faces. So does this prism. This prism, rectangular prisms, always have 6 faces. Once again, we're going to start with this end. This end has a base of 6, has a height of 4. We don't want to get confused by that 5. Has a height of 4. And since it's a triangle, to find its area, we have to divide by 2. 6 times 4 is 24. Divide that by 2. You get 12. And the thing about starting with the ends, it doesn't matter what kind of prism it is, here's something we always know. The ends are the same. Doesn't matter what kind of prism you're looking at. The ends are the same. The ends are the same. The ends are the same. So since the ends are the same, we can take that 12, stick it up here, put another 12 right after it. We have 2 of our 5 faces. Let me get rid of my triangles here. Get them out of the way. I think while I'm at it, I'll get rid of all of these as well. Bring them all down, clump them up together, put them in the trash can. So we are ready to do the next face. Now, since this is an isosceles triangle, here's a 5. This side's also 5. You can see it right there. Since that's 5, it means that's 5. It means that this side and the side opposite will be the same. So let's calculate this one, 18 by 5, and then we'll show you why we know the other is the same. So we have 18 times 5. Let's get out our calculator. Once again, real tools for real problems. 18 times 5 is 90, and I can stick a 90 up here. And I can also, let's put that away temporarily. I did all these in parts. Well, you know what? Since I did them in parts, let's use these 2 parts. So that, again, along with these 2 sides, those are identical to what we just did. Here's a 5 again, and this 18, I could have left it there, is the same as that 18, which means we once again have 18 times 5, which means we once again have 90. So anytime the triangle for your prism is isosceles, I'm gathering all, it's like playing pickup sticks here, gathering all my parts here to get rid of. Anytime your triangle is isosceles, you know that both of the top faces of your prism are the same. Now we just need to calculate the bottom face. And the bottom face right here is 6 times 18. It's just going to be one more 18 than this last answer, so you probably are already looking at it going, man, I don't need a calculator. I could just add an 18 to what I already had and get 108. Let's get a better 0 than that. 108. I'm going to stick it right there. And we're going to add all those together. So we have 108 plus a 90 plus a 90 plus a 12 plus a 12. And all of that equals, I can see I have 1, 2, 3, 4, 5 numbers. All of that equals 312. So A is 312 centimeters squared. Now, you might have put it in the calculator by doing the 12 times 2 and put in a 24 and do the 90 times 2 and put in a 180. It doesn't matter. I like doing it this way. I do all the answer keys this way because I want to make sure that I get all 5 sides. And it's just an easy way for me to see that I've all 5 of my sides there. B is also a 5-sided figure. We start out the same way. We start out with, grab some purple here. We start out with these 2 ends. And we know that these ends are 6 is the base times 8 is the height divided by 2. Since they are triangles, 6 times 8 is 48 divided by 2 is 24. So I'm going to have a 24 and another 24. Let me draw my line right now so I keep separate my work from when I get to part C. All right, let's get rid of those. Get those out of the way. Now, since this is not isosceles, 8 and 6, not isosceles, we actually have 3 different sized faces to measure. So we're going to have to do 3 separate measurements. So let's do this back first, which may look like the front as soon as you highlight it. It is 8 high and 10 long. It's the same 10 right there. So it is 8 high and 10 long is 80. No dividing by 2. It is not a triangle. It's a rectangle, so nothing to divide by 2. All right, let's get that out of there. And let's go ahead and do our next face. Let's do this face. That's the one that looks to me like a front. This face is 10 by 10. It's pretty straightforward math to do. 10 by 10. And then we have one more face, and that's the bottom. And it doesn't matter which order you do them in. I tend to work my way around and seem to end up with the bottom last for some reason. I don't know why. Order doesn't matter as long as you get all 5 of them. 10 by 6. So that's going to be 10 times 6, which is 60. And now I have the 5 faces, and I'm ready to add them all together. 24 and another 24, 80, 100, and a 60. 1, 2, 3, 4, 5 numbers in my calculator. 288. 288. So I have 288 centimeters squared. And I'm ready for my last, ready for my last figure. And so for the last figure, once again, I like to start with the ends. Now remember, this figure is a rectangular prism, so whatever one end is, you have the same at the other end. And this will be true on all sides of the box. It's like holding that box of Kleenex or holding a cereal box. It doesn't matter as long as you put your hands on opposite sides of the box, your hands are on surface areas that are the same, that are equal. So that first part is 4 by 5. This 5 right here is the same as this 5 right here. So I have 4 times 5 is 20, and I have 2 of those, 1 at each end. All right, let's get rid of the 2 of those, and let's put in our next side. Our next side is right here, and that side is 14 by 5. So 14 times 5. 14 times 5 is 70, and I am going to have 2 of those because that 70, we pick it up, is the same as that 70. These 2 sides, this front, this back, are the same. Okay, let's put that away. And let's do the top, which is also the bottom. And I'm going to place it on the bottom actually because that's where my 2 numbers are, my 4 and my 14. realize when I'm finding that, I'm finding the top as well. I'm finding both of those. So I have 14 times 4, 56, which is, by the way, 14 less than 70 because I have 4 14s instead of 5 14s. So 56, time to add, we have 56 plus another 56 plus a 70 plus a 70 plus a 20 plus a 20 equals 1, 2, 3, 4, 5, 6 numbers, yes, 292. 292 centimeters squared. And now I'm ready to place them in order. Least, well, 288 is the smallest. That would be B. To greatest, A is the largest, which means C is in the middle. BCA. BCA going least to greatest. Okay, I know that was a long video, and I appreciate you sticking with it. This is something that can be complicated, can look really complicated, but if you break it down into those parts, if you will do what we did in these problems and show all 5 sides and really take it slowly, I know you can be successful with this. If you have additional questions, feel free to bring them to class. I'm happy to answer those. And again, thanks for sticking with us.